Hi guys, I miss you all so much. Welcome back. This is my very first video lesson, and not gonna lie, YouTube is taking forever to upload these videos, so we're gonna see how this goes. But today we're going to look at some similarity theorems. There are 3. Hopefully last week's lesson on Friday on Khan Academy introduced those 3 theorems to you. So I'm just going to briefly kind of go over them. They are pretty familiar to you. You've heard of them before in our congruency unit. So this should be pretty quick and easy. They are SSS, which stands for side, 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 and that theorem just states that if 2 triangles have 3 proportional, so not congruent, but proportional sets of sides, then they are similar. All right, remember, similar figures don't have to be exactly the same, but the side ratios have to be proportional. SAS theorem, similarity theorem, I should say, says that if 2 triangles have 2 proportional, again, proportional, not congruent, sets of sides and 1 included angle that is congruent, then they are similar. You remember the word included means between. So the congruent angle has to be nestled nicely in between those 2 proportional sides. And then AA. AA says that if 2 triangles have 2 congruent angles, then they're similar, period. So instead of doing like ASA and AAS, it's kind of nice because in our similarity unit, we just have to have 2 sets of angles and that's it. They will be similar triangles. The reason why we don't need the third is because think about the triangle sum theorem. If I had, I'll draw you a little example here. This is terrible. If I had like a 60-degree angle in common and like a 40-degree angle in common, then by default, this angle here, the missing angle, has to be 80 degrees because they have to add up to 180. Same over here. So you really only need 2 of the angles to match up because by default, the third angle will match up. Okay, so that's what we're going to take a look at today. First, we're going to look at some examples. These are your interactive notebook, or what would have been your interactive notebook notes. So we're going to go through it just like we would normally. Is either triangle PQR or triangle STU similar to XYZ? So you can see we have 3 side lengths labeled. We know nothing about the angles. So this one would only fall under the SSS category. So I'm going to put SSS question mark. All right. We know we're talking about triangle XYZ. So I'm going to list the side lengths for X, Y, and Z in the numerator. And, oh my goodness, what am I doing? That should be 15, and that should be 30, Miss Brian. I'm already screwing up here. Sorry, guys. All right, so 25. On PQR, 25 would correspond with 35. 15 would correspond with 21. And 30 would correspond with 42. If all of these ratios are the same, equivalent, then that means these 2 triangles are similar by SSS. Okay, so 25 over 35, if I reduce that fraction, I'm going to divide both of those numbers by 5. I get 5/7. 15 over 21 are both divisible by 3. I get 5/7. And 30 over 42 are both divisible by 6. I get 5/7. So I just happened to land on the correct answer the very first time. I know that PQR, I'm going to be very careful when writing this similarity statement. Triangle PQR is similar to triangle XYZ by SSS similarity. Awesome job. Okay. I guess I'm talking to myself and telling myself I did an awesome job. Here we go. Is DEF or GHJ similar to ABC? Okay, so we got DEF, we got GHJ, and we have ABC here. I'm going to go ahead and have you look at these triangles really quick. I bet there's one that you could rule out just by looking at one set of sides. I noticed it right off the bat. The long leg of both of those triangles are the same. They're both 16, but the other sides are not the same. From one to another, we have 8 and 8, but then we have 10 and 12. So that immediately rules that one out for me. So I'm just going to double check here that these two triangles would indeed be similar. So remember, it doesn't really matter how you write your fractions because we weren't given a direction. So we're just going to assume that we're going from small to big because I'm putting the bigger number in the numerator, but you could do it the other way as well. Okay, so 16 over here corresponds with 12. We have the medium side is 12 over here, corresponds with 9 on the other triangle. And I'm running out of room, sorry about that. And 8 corresponds with 6. So I just want to know, are these proportional? If so, then these two triangles meet SSS criteria. Okay, so 16 and 12 are both divisible by 4. And that would give me 4/3. 12 over 9 are both divisible by 3. So also 4/3. 8 over 6 are divisible by 2. And that's going to give me 4/3. That tells me triangle ABC is similar to triangle DEF by SSS similarity theorem. Woo! All right. This last one, I'll let you kind of press pause on your video if you'd like and do that one on your own. Okay.